Welcome back. We're now going to talk a little bit more about the atom, and we're going to focus in on subatomic particles here. So subatomic particles include protons, neutrons, and electrons. Like we established last time, the nucleus is positively charged. That's where the protons and neutrons are, and the electrons are surrounding it. So we can see the important things we want to know about each particle are their location, and then their relative charge. So protons are positively charged. Neutrons, like the word neutral, have no charge, and electrons have a negative charge. And we say they're the relative charge, it's kind of relative to each other. We could also define that charge in terms of coulombs, which we don't use much, but I put it down here for you. And then we also want to talk about the mass of each. So we're going to say a proton has a mass of 1 AMU or U, which is atomic mass unit. Neutron is also 1, and then electron's pretty much 0. It's significantly smaller than 1. So here would be its actual mass in atomic mass units, but we'll often just say there's no mass for electrons. So basically, it's the protons and the neutrons that give an atom its mass. Elements are defined by their atomic number or their number of protons. And in the modern periodic table, which we'll be working a lot with, atoms are arranged in order by atomic number. We'll kind of get into why it's shaped that way a little bit later when we talk about electrons. We can also talk about the number of protons as the nuclear charge, because remember, protons and neutrons are the only particles in the nucleus, and protons have a positive charge and neutrons have no charge. So if an atom of lithium, for example, has an atomic number of 3, that's what identifies it as lithium, and it also has a nuclear charge of 3 or plus 3 because of its 3 protons in the nucleus. Here's the most up-to-date version of the table. And again, you can see there, if you go across and just kind of keep reading across, they're in order by atomic number. The names are there, the symbols are there. We'll talk a little bit later about those atomic masses. So neutrons are also going to be talked about here. And they also, why? Because they contribute to the mass of an atom. So the mass number is going to be equal to the number of protons plus the number of neutrons. Okay, and this is an exact number. We're kind of a little bit in the theoretical here. We're talking about, if I had one atom of carbon, 14, let's say, right? The mass number would be 14. That one atom of carbon would have 6 protons and 8 neutrons, right? A little bit later, we'll talk about like when we have a sample of carbon, which includes many, 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 many atoms of carbon. But for now, we're just kind of talking about, what if we had just one atom, and if it was carbon-14, it would have 6 protons because it's carbon, and then 14 minus 6 equals 8 neutrons. So here's a couple practice questions based on what we've talked about. Maybe you want to pause and try them. So the atomic number of calcium, you're going to need your periodic table, is 20. The nuclear charge on an atom of fluorine is going to be 9 or plus 9. Iron symbol is Fe, it might take you a minute to find that, has an atomic number of 26, so it has 26 protons. And an atom of sulfur has atomic number of 16 protons. That's also going to be equal to the number of electrons for neutral atoms, which is what we're talking about right now. What's the mass number for carbon-14? Well, the mass number has to be given to you. It's not found on the table, and it's the number after the symbol or the name. The atomic number is 6, because that's carbon. So it identifies as carbon. Same thing, the protons are 6. Okay, and the neutrons would be 14 minus 6, which would be 8. Remember, protons plus neutrons give you the mass number. Next time, we'll talk a little bit about isotopes.